All right, let's come to problem 8. So we have a set of 6 numbers from 1 to 6. We want to split into 3 different groups. And then we want to count how many such splitting are possible. And here, empty set is not included. And the order does not matter. So for this requirement, there are only 3 cases. So based on the number of elements in each set, there are only 3 cases. The first case is that we have a set of one number, and a set of 4 numbers. So one number set, and 4 number set. Okay, here the number means how many numbers in each set. Okay, and the second case is we have the first set has 1 number, the second set has 2 numbers, and the third set has 3 numbers. The third case is that all the 3 sets have the same numbers. That's 2. Okay, 2, 2, 2. Because the order does not matter, so we don't consider empty set. These are 3. We only have these 3 cases. Okay, now let's calculate how many splitting for each case. So for the first one, because the first 2 sets have the same number, so we only need to assign 4 numbers to the third set. So that means 6 number, we choose 4 to assign to the third set. This corresponds to 6 factorial, 4 factorial, 2 factorial here. That means this is 15. Okay, we have 15 ways to in the first case. And then for the second case, okay, let's assign 1 number to the first set. So we choose 1 from the 6, and then we have 5 numbers remain. From these 5 numbers remained, we choose 2 numbers to assign to the second set, and then the remaining 3 go to the third set. So here we have 6 times 10 times 1, which is 60. There are 60 ways to do this type. The third case, 2, 2, 2. So okay, we choose 2 number to the first set, and next 2 number to the second set, and the last 2 number to the last set. Okay, but we see that all the sets have the same numbers, so same number of numbers, so they can permutate. Okay, so we divide by 3 factorial. Okay, because the order does not matter. So that's the answer. So this is 15 times 6 times 1 divided by 6, which is 15. Now we add these numbers together, we get 90. So the answer is 90. All right, now let's consider problem 9. It's a plane geometry problem. We want to calculate the area of this pentagon. So here we see that we can draw this altitude from E to BC. Let me add this line here. So let's call it F, okay, EF. So EF perpendicular to BC. We know that AEBF is a rectangle. Okay, maybe ABFE. Is a rectangle. That means BF equals AE equals 2. Okay, BF equals 2. And then we know BC equals 5. So we get FC equals BC minus BF, which is 5 minus 2, which is 3. So this FC is 3. And also we have EF equals ABE equals 4. So this is 4. Now we can basically connect EC So EFC is a right triangle. And EF equals 4, FC equals 3. So we can immediately calculate EC. Okay, EC equals 5. Okay, EC equals 5. And then we consider triangle ECD. This triangle is with side lengths 5, 12, 13. We know 5 square plus 12 square equals 13 square. So this is a Pythagorean triple. And we can conclude that angle ECD is a right angle. This is 90 degrees, okay? So basically we can split this pentagon into two parts. One is the trapezoid, the other one is the right triangle. So we just can consider the area separately. So for the trapezoid AECB, the area is 1/2 times 2 plus, okay, AE plus BC, so 2 plus 5 times the height is 4, which is 14, okay? This area is 14. And then we consider the triangle, right triangle, ECD. The area is 1/2 times the base. Let me take CD as the base. 12 times the height, EC as the height, which is 30. So the answer is the sum of these two numbers, 14 plus 30, which is 44. So the answer is 44C. All right, question 10. We have these 9 numbers placed in these 9 boxes. And we have each group, okay, we have 3 groups. Each group have the same average. So we want to find a number between 7 and 11. All right, here, let's assume the average, this common average, to be X, okay? That means for the first group, we have 2 boxes. The sum equals 2X. And for the second group, the sum equals 3X. For the third group, we have 4 boxes, so the sum equals 4X. Now, if we add these numbers, 2X plus 3X plus 4X, that's the sum of all these numbers. Okay, and we know this numbers is 1, 5, 6, 7, 11, 18, 19, 20, and 21. And this sum we know is equal to 108. But on the left hand side, this is equal to 9x. So 9x equals 108. That implies x equals 12. Now we know the average. And now let's come to the second group. We have 3 boxes. So 7 plus this unknown plus this 11, that's 3x. And 3x equals 36. So this unknown is 36 minus 7 minus 11, which is 18. So the answer is 18. All right, let's come to problem 11. This concerns calculation with repeating decimal numbers. And so here, let me provide you first solution, which is a little bit complicated, and later I will show you an easier one, okay? The first solution is based on the fact that we can always write a repeating decimal number in terms of fractions. So for example, the first number, let me denote by x, 0.513 repeating. We can express x in terms of fraction in the following way. So we multiply everything by 1,000. This corresponds to 513.513 repeating. And then we do subtraction. We get 999 x equals the difference. So when we do this subtraction, we cancel this repeating part, and we only have 513. So, and then we can express x in terms of fraction, 513,999, and you can simplify it to get 19/37. And similarly, let's consider the second part. Let me denote by y. Y equals 0.54 repeating. And then if I multiply by 100, I will get 54.54 repeating. And then we do subtraction. We get 99, y equals 54. And then y equals 54 divided by 99, which is 6/11. Okay. And finally, we consider z equals 0.1 repeating. And then we multiply by 10. So 10z equals 1.1 repeating. We still do this subtraction. And that gives us 9z equals 1. So z is 1/9. And so we are able to do this calculation. N equals x minus y plus z, which is 19/37 minus 6/11 plus 1/9. This is a complicated computation. So this corresponds to 290/3663. And then we write this in terms of decimal number. This corresponds to 0.79170 repeating. And so the answer is, so A plus B plus C plus D plus E plus F, 0 plus 7 plus 9 plus 1 plus 7 plus 0. The answer is 24. So the answer is 24. Okay, this method is universal. It works for all cases. We can always write the repeating decimal number in terms of fraction. But for this particular problem, this is not the best way to do it. It takes a lot of time by using this method. Now let me introduce you another way to simplify the calculation. Method 2. So the idea is as follows. So x equals 0.153 repeating. We can rewrite this repeating pattern in the following, because the first number has 3 digits, the second number has 2, the last number has 1. So the least common multiple of this 1, 2, 3 is 6. So that means we are able to write each of these numbers as a repeating number with 6 digits. For example, x, we can write this as 0.513513 repeating. That's equivalent, okay? And similarly, y is 54 repeating. So this is equivalent to 0.545454 repeating, okay? And z is 0.1 repeating. This is equivalent to 111 repeating. So now they have the same number of digits, and we can do the calculation easily. X plus y plus z is 0.513 minus 545454 repeating plus repeating. And basically we can change the order to simplify the calculation. We can first do addition to make this sum as large as possible, and then subtract this term. This gives us the first 2 terms add to 624, and then subtract 0.545454, and this calculation is not too difficult. It's 0.79170 repeating. Okay, and then we get a solution. So the answer is 0 plus 7 plus 9 plus 1 plus 7 plus 0, which is 24. So we get the answer 24. The second method is much simpler than the first one. And the first one is universal method. You'd better to know it, okay? All right, problem 12. So we have a tiny spore of radius 1 inside of a cubic box of side length 4. So we want to calculate, okay, what fraction box internal surface area that cannot be touched by the spore. So because this tiny spore or this box, cubic box, are symmetric, so we just need to consider one face. For example, let me show a picture. Suppose we have this box, right? So let's consider front view. Okay, we consider the bottom surface. How much area of the bottom surface can be touched or cannot be touched. So let's consider the front view. So let's just view from front. So let me just draw this picture. The side length is 4. And the radius of the tiny spore is 1. So if the tiny spore moves to the corner as much as possible, it gives the following picture. Let me still use blue. Okay, this is like the leftmost position for the tiny spore. The bottom of the tiny spore touches point here. And if moved to the right, the bottom of the tiny spore can touch up here. So the part can be touched is this part, right? This part. This is just the front view. And if we view from different face, that's the same picture. Now let's consider the bottom surface. If we consider the bottom surface, we see that the area can be touched will be the center square. Okay, because this is 2. Okay, this is 2, and this whole side length is 4. So the area can be touched in each face. On each face is a square of 2 by 2 square. This is the area can be touched. Yeah. And now cannot be touched is the area outside of the square between these two squares. So okay, so the answer is just the total area. Okay, the total area is 4 square. Subtract area of can be touched, so it's 2 square over the total area 4 square, which is 12 over 16, which is 3 over 4. Okay, of course here I just calculated one face, but this is the same for each of the faces. So the answer is 3 over 4. All right, problem 13. This is a logic problem. We have 4 people. Some of them always tell the truth, some other always lie. So we have 4 statements from each of these persons. Now let's consider the first 2 statements. The first person said, an odd number of us always tell the truth. So if this is true statement, that means odd number of people tell the truth. We have, because at most 4 people, we have 1 or 3. We only have 2 odd numbers. So that corresponds to the first statement. Now let's consider the second statement. The second person said an even number of us always tell the truth. That means we could have 2, 4. Okay, maybe 0. 2, 4, 0, 2, 4 persons tell the truth. Okay, and we see that for the first 2 persons, 1 must lie, 1 must tell the truth, because 1, 3 is odd, 0, 2, 4 even. They just contribute. They don't have any overlap, and that's all numbers possible, right? So we conclude that for the first 2 persons, we have one tells the truth, and one one statement is true statement, one statement is false statement. Okay. All right. Next, let's consider the third person. A prime number for us always tell the truth. So that corresponds to 2 or 3. We only have these two prime numbers from 0 to 4. The fourth person said a square number for us always tell the truth. For square number, we have 0, 1, and 4. So by similar reason, we know that for the third person and the fourth person, we have one true statement and one false statement. Okay, so although we don't know who tells truth, who lies, but we know there are two persons tell the truth, two person lies. So the answer is 2. Okay, the number of people telling the truth is 2. Okay, that finished the problem. But now we can just take one more minute to to tell which person tells the truth, because we have two person tells the truth. We can check the statement of each person. So for the first person, it says odd number of us tell the truth. This is wrong because we have two person tells the truth. The second person says an even number of us tell the truth. So this is true statement. The third person says that a prime number of us tell the truth. That's correct because 2 is prime number. And the fourth person says a square number of us tells the truth. That's wrong because 2 is not a square number. So now we know everything clearly. Answer is 2. Okay, problem 14. We have a circle, radius 1, centered at O. This O. Okay, and then there's a point P outside the circle. Suppose we have P here. Now we see that we randomly draw, okay, randomly, this is a typo. We randomly draw half line starting from the B. So there are a lot of ways to draw this half line. So half line. And for some lines, it intersects this circle. Okay. Okay. The probability that the line intersects with the circle is 1/4. What's the distance from P to O? All right, now we consider this like drawing a half line. It's like to choosing one direction. So totally we have all direction that corresponds to 360 degree. And then for certain direction, the line touches, okay, the line cut, okay, intersect the circle. There are two extreme direction that corresponds to the line tangent to the circle. Okay. And the direction spanned by, okay, within these two red lines, if we draw half line to this direction, it will intersect the circle. Now the probability is 1/4. That means this direction accounts for 1/4 of whole directions. So we have totally 363. So this 1/4 of 360 degrees is 90 degree. That means this angle should be 90 degree. Theta should be 90 degrees. So let me draw a correct picture. So P may be here. So I'm drawing 90 degree. This is P. 90 degree. Okay, now this shows us the position of P. Sorry, okay, this is O. All right, the radius of the circle is 1. So if I draw a line from O to the tangent point, A, this is B, we know AO is perpendicular to this red line. BO is also perpendicular to this line. And APBO is actually a square. And the radius 1, so this is a square of side length 1. So PO just corresponds to the diagonal, and that's square root 2. So the answer is square root 2.